house type building where they'll come in and do, they can take the engine out of the airplane and just run with the engine, or leave the engine in the airplane like we have now and run it to do different checks and maintenance things on the airplane itself. Okay, so I'll let these guys come and talk about stuff because they're the experts. You're going to be our speaker today?
Yes, sir.
About things. And you guys can ask him any questions, and then he'll tell us where we're going to go probably inside there. So come on up and talk about stuff if you want to.
Thank you, sir. So my name is Sean Gerdman. I'm actually the phase dock supervisor, so we actually tear it apart and work on it. I'll give you guys a heads up here in a second. But this is Kevin Jones. He's one of our engine guys, and he'll give you guys a quick safety briefing on the hush house just in case anything major was to happen. So, Kevin?
All right, just safety-wise, everybody, we're going to watch the engine run from inside this room here. With the airplane in here, it just gets kind of other safety issues that it's best if we're in there. As you walk around the jet, just watch your step. We have hundreds of things to trip over, and with the jet here, there's hundreds of things to hit your head on. You will lose every time. So just be careful and watch your step. If anything happens, we don't foresee that happening, but you just never know. I'm going to be in that room with all you guys. I will take everybody out, and we're going to meet up on this taxiway up here. The guys left behind, they'll handle the situation here, and fire department or whoever will come at that time. That's kind of it for safety. It is kind of cramped in there, so we'll have to kind of rotate around so everybody can get a good view of the jet when it's running. You can take pictures. I think that's about it for safety's sake. Okay.
Thanks, Kevin. All right, so like I said, my name is Sean Gerdman. If you guys have any questions, please just raise your hand anytime or ask away. I have no problems with that. So as far as pictures go, there's really nothing you can't take a picture of right now. We don't have a stand-up next to the cockpit. Sorry about that, but if we did, you could get in there, just no pictures of that. So we'll start by just kind of coming around to the front here, and we'll kind of work our way around this way. So this is our F-16C model. We fly Block 30. Block 30s here, so when people talk about F-16s, we generally talk about it in blocks. Block 30 is one of the older blocks of aircraft that are still flying as far as F-16s go. They go all the way up to Block 60s, but it's mainly foreign service who fly Block 60s. And really, when you're talking about the different style blocks, it's not going to be the way the airplane looks, but more of the systems that it flies with, the electronics and things. As you can see, our aircraft is very rounded. We don't have a lot of flat surfaces on it, obviously, albeit our wings and things like that. But what that does is we don't have a stealth capability per se, like a 22 or an F-35. So what this does with this rounded look on it is it reduces our radar signature when they're pinging radar at us. So the size of the F-16 actually makes us look considerably smaller with the way it's shaped and everything else. So we'll come around this way. And like Kevin was saying, just please be careful around the surfaces. From falcon bites, you don't want them. You'll never get rid of them. So you can see the way it's loaded right now. This is generally how we fly our aircraft. We're mainly an air-to-ground mission here in our operational wing. We fly with 9 full weapon stations, counting from left to right. Station 1 obviously being the wingtip. Station 9 obviously being that outside wingtip. On Station 1s, we're always going to fly missiles. Generally fly our AIM-120s on our Station 1s, and then we'll also, right here, we're flying missiles as well. This station right here is going to be mainly our bombs. We can fly the big boys if we need to, the 3,000 pounders. We've done it before, and if we need to, we can load them there. This right here is not a bomb, as some people may think it is. It's actually an external fuel tank. It's about 370 extra gallons of fuel. We can load one. As you guys will see, it's on both sides. Stations 4 and 6 are our 370-gallon external fuel tanks. Without these on here, we're looking at about a 0.8 to a 0.9 mission, depending on how the pilots fly and everything else. But without these fuel tanks, we're generally an air-to-air setup, so better maneuverability. We can pull more Gs, things like that with the aircraft. With this particular setup, it's for range. So if we need to go in and drop a bomb and then make it back home, this is what this does for us. These will always empty first, so these become empty pretty much right after takeoff. We can also load an external fuel tank on the center section where that pod is right now, and that's 300 extra gallons of fuel. So in total, we can load about 1,040 extra gallons of fuel on our aircraft, excluding our internal part, which is about from where it says walkway back is going to be mainly all of our internal fuel, as well as the wings and an auxiliary reservoir up front. So
what's the total gallon you can carry?
Total gallons,
1,300, 1,400?
so when we don't have any external tanks, we put about 700, what's that, sir?
External tank, 7,000 pounds.
7,000 pounds, so it's about 7.1394 pounds to the gallon. So,
okay, 900.
So yeah, so about 900 gallons of fuel is about what we can do with no external tanks.
Just one more question. Could you ever, if you were on a really mission critical air combat, substitute weaponry in the place of the hanging pod area?
Yes, so this is a weapons station. We just hang external fuel tanks here, but you can hang auxiliary weapons here if you need to. These tanks can also be, if the colonel was flying and he needed to jettison these external tanks for an emergency situation, these are ballistically jettisoned. So you have basically 2 shotgun shells in here, and if he has to fire them, he has a button in the cockpit he can hit, and it will fire those shells and shear a bolt, which allows the tank to fall away from the aircraft.
And it then gives them greater aerodynamic ability.
Greater aerodynamics, or if he's in an emergency situation where he has reduced engine power or something like that, immediately jettison tanks because you're getting rid of that drag and the weight at the same time. So yeah, it's ballistically fired off the aircraft if it needs to be. Obviously not salvageable after that. So, so we'll keep coming around this way.
What's the machine gun?
Oh, I'm sorry. Yeah, real quick. I'm sorry. I forgot about that. So this is our 20 millimeter gun, Gatling gun right here. 6-barrel Gatling gun. Can't really see it. I kind of tucked back in there a little bit. But the example I always give to it is the 810. The 810 flies with a 30 mil, and I'm sure everybody's seen that. It's a huge barrel. You know, they're very powerful, and the shells are about that big on it. Ours are just 20 Mike shells. We fly what we call our HEI rounds, which are high explosive rounds. And that's what we mainly fly with when we do active missions. I don't know what the colonel flies with when they go out to the range. I think just regular rounds. But so up in the center section there is our drum. We can carry over 500 rounds of ammunition, and we can fire it all off. How fast can you fire all that off, sir, if you're just to get rid of it?
I think he said 5 seconds before.
How fast can you get rid of all the ammo if you need to, sir, on the gun?
Oh, like the gun? Or
Yes, sir, the gun.
5 seconds to get rid of all the bullets.
5 seconds. Hold it down. Done. Doesn't take very long to get rid of it. So it's pretty quick. Pretty quick you can get rid of it. So the gun, you can see where the barrels are at. It only extends to about right here. Right here is going to be our gun mechanism. Like I said, on an A10 where the gun is at in the nose, it's about halfway down is where your drum and all your mechanism and stuff's going to start. So considerably smaller as compared to an A10, but once again, we're more air-to-air, kind of lethal, kind of that, you know, that instance. So, all right, so we'll just walk around back this way. So just standing from back here, you can kind of see the F-16 is a very small fighter. It's not your F-15, not your A-10. They're huge. You know, they sit really high, and they're just big, lumbering airplanes. Ours is, I like to say, very sleek, unique, petite. We do it, you know, what we need to do to get it done. So our wings are very short, and in that instance, we don't have things like spoilers and slats that will reduce airspeed. This is what we call our flaperon, which is an integrated flap aileron. So it helps when he's coming in on landing to provide lift and things like that, but it also provides our roll control. On the front of the wing, the entire front part of that wing is called our leading edge flap. And that flap will actually rotate to 25 degrees down, or as you will see on the other side, it's 2 degrees up right now. That also helps with control and maneuverability. Obviously, the flaperon is going to be controlled by the pilot and the inputs he gives off his side stick controller, but the leading edge flaps are going to be controlled mainly by the aircraft. There's 2 probes up front, which I'll show you guys at the end, and the way those rotate or the way those leading edge flaps will move. So it really takes the thinking out of, I need more maneuverability, okay? The F-16, very unique to it, is an all-digital aircraft. So it's all paneled up right now, so you can't see the over 2 miles of electrical wiring we have underneath and fiber optics and the really thin stuff. Up front is a giant computer, and that computer sends signals back to what we call ISAs, integrated servo actuators, and that's what moves our flight controls. We don't have cables like you see on airlines with turnbuckles and things you have to tighten and adjust. These are going to be anything RC. If you guys ever have done RC, receiver sends a signal to a servo moves the flight controls, same kind of difference. We call them electromechanical, takes an electrical signal, turns it into a mechanical output. So very interesting, huge servo right on top connected to a hydraulic actuator, and that's what moves our flight controls. So it takes a lot of the work out of rigging flight controls for mechanics. When we replace ISAs, we do rig them, but it's all basically based on a measurement and then you tighten and loosen a turnbuckle within the ISA to adjust it if you need to. So it takes a lot of work out for us, which is great.
Sir, sorry. What's this for? Ejector fuel?
No, these are actually just static wicks for static discharge. If you have any
Oh.
static electricity built up, they'll just come off and
Oh.
basically be ejected
Oh,
off
no.
the side there. So not really too fun or important, but something you always hit your head on, and I don't like them. So stabilizers here, like I said, every flight control has an ISA. So we have 5 total, 1 for each stab, 1 for each flaperon, and then 1 for our rudder. So very simple when it comes to flight controls. We don't have any of those slats or spoilers. Everything is basically what you need for moving and turning. These are going to be our speed brakes here. Our speed brakes will go full open. Takes a little while, but they'll go open about that much. And these are going to be the only thing that we have to bleed our airspeed off. And then obviously when the aircraft lands, the pilots are at a very high angle of attack, so they'll flare out that nose for a long time before they actually set it down. So once you're down on the ground, the only thing that's going to help you stop is brakes at that point. And as you can see, our wheels, not very big. So our brakes are even smaller than that. So once you burn those out, you're going to blow tires, and it's never a good situation after that. So we'll just come around back here. Are all F-16s equipped with a tail hook? Yes, they are. And actually, the tail hook, just real quick, we'll talk about that. Our tail hook is not designed, it cannot land on an aircraft carrier. It will be sheared off. But we use the tail hook. The pilots use it as an emergency arresting system. So if they were to lose brakes on landing, they could drop the hook, drag it, and grab the barriers on either end of the runway. We also use it to tie it down the hush outs for high power runs. So, but not very strong. Every time they catch the barrier like a test, which they test I think every month, they always break. It never fails to break. So, not break off, but it breaks components. So this is our GE F-100 engine. There's 2 types of engines that the F-16 flies with. It's either going to be a GE or a Pratt & Whitney. Our engines goes about halfway up to our 341 bulkhead, which is our major structural bulkhead on our aircraft. But this section back here is mainly going to be our exhaust section, our augmenter section. So just real quick, people, I know the afterburner, everybody says afterburner, afterburner, afterburner. Well, an F4 flew with an afterburner. You know, it was real dirty and smoky when they'd kick those flames. It was an orange flame. Well, what they did is they took hot exhaust gases and they would re-inject that with fuel and light it, which would give them that afterburn. Well, we call it an augmenter. So what it does is on the intake, that huge mouth on the front, it takes bypass fresh air down the side of it. If it's not used, it just comes out the back. If it is used, an augmenter, what'll happen is they'll actually inject that fresh air with fuel, light it off, so we get a really clean blue flame, which you guys will see when we're running, and get a lot more power out of that, and it's really clean, you know. And then because you're injecting oxygenated air with fuel and spark out the back, so you get a lot more power, and it's like I said, a cleaner burn rather than those old F4s. So I say augmenter, not afterburn. You always want to augment. Come around this side over here. So kind of the same thing over here, same as the other side, our ventral fins. Most people think it's just hey, look at this, but it actually helps in supersonic flights. It makes it better stability, one of the aerodynamic features. But once again, our weapon stations. And then these right here are, like I was saying, those leading edge flaps that will drive 25 down. Right now they're in the 2-degree up position, which is what they're pretty much always in when they're on the ground. Once he comes off of takeoff and the weight comes off the wheels, these will drive to a 0-degree streamline position. And then they're controlled for maneuverability and controlling things by those 2 AOA probes up on the nose, which I'll show you guys here in a second. So. Another feature, this is our EPU. We call it our emergency power unit. What that does is if he was to lose any critical system, electrical, hydraulics, it's got its own pump and its own generator installed on the EPU. It's run off of a fuel called H70, 70% hydrogen and 30% benzene. Very carcinogenic, very bad for you. You don't ever want to be around it. Nasty, nasty stuff. What happens is if he was to lose the engine, which runs everything, our pumps, our generators, everything, this would feed fuel to the EPU. We get about 10 minutes of emergency hydraulic systems to critical systems, which is going to be limited flight controls and things like that, and then electrical power for what he needs to obviously get out of the situation, generally to just take it to a safe area to punch out if he needs to. If the engine was running and he lost electrical power, he could run the EPU for as long as he needed to get back to base or whatever, because it will run constantly off of ram air. So it doesn't always have to run off EPU fuel, and that's just if he loses a motor and all the systems. So.